Before we dive right back into polynomials, let's review 3 of the exponent rules. So I have them listed here. A to the m times a to the n equals a to the m plus n. So this is a little bit abstract, but notice we have multiplication over here, a to the m times a to the n, and it equals a to the m plus n. Okay, so multiplying bases to different powers, same base, different powers, multiplying, ends up with the base to the powers being added together. So let's look at an example just real quick. If we have 2 squared times 2 cubed, what does this mean? What is squared or cubed? Squared means 2 times 2. Cubed means we have 3 2's, 2 times 2 times 2. Okay, so how many 2's do we end up with altogether? We have 5 2's. So 2 to the 5th. So notice if you just add 2 plus 3, you get the 5th power. The base stays the same. That's why this rule works. Okay, let's look at the next one. A to the m, all of that raised to the n, is a to the m times n. So here we have a base to a power raised to another power, and it ends up being the base with the 2 powers this time being multiplied instead of added. So let's look at an example there. If we have, let's say, an arbitrary x, okay, being raised to the 3rd power, and let's say that that is to the 4th power, that means x cubed 4 times, right? X cubed, x cubed, x cubed 4 times. But what does each of these x cubed means? It means x 3 times. X, x, x. And then x, x, x. So how many x's do we end up having? 12 of them. Okay, so that ends up being the same thing as if we would just say x to the 12th power. So 3 times 4 is 12. That's why this works out. What about anything, any number to the 0 power? It's just 1. Okay. So this works out. Let me go ahead and get a fresh page here. Okay, if we have, this is what we're working on right now, a to the 0 equals 1. So why does this work out? If you think about a number, let's say we have a squared, okay? A squared over a squared. How do we simplify this? Well, anything over itself is just 1, right? But how else could we simplify it? A squared over a squared. I don't know if you remember the exponent rule that tells you that if you have exponents like this with the same base and exponents, then you subtract them. Okay, just like when we were multiplying, we added. Well, when we divide, we subtract. So a squared minus a squared. I'm sorry, a squared, a to the 2 minus 2. So what's 2 minus 2? That's just 0. So we have a to the 0 is this, but this same thing is also 1. So that means a to the 0 is 1. And this is for any arbitrary a. Okay, so any a is 1. And if you're not sure, you can plug it in on your calculator and you will see that it works out. How do you type in a to the 0 on a calculator? Let's see if we can pull that up real quick. Minimize this. Nope, can't do it. Okay, there we go. So if you want to type in, let's say 5 to the 0 power, use this caret button right here. Okay, that will give you an exponent. 5 to the 0, enter. And it's just 1. Okay, great. All right, let us go back to our Polynomials. Okay, so that's where we're going to begin with our polynomials. Okay, sorry, one second. Polynomials. Okay, so let's work with polynomials. Do you remember what they are? We have some examples maybe. Polynomials are a bunch of different monomials strung together with addition or subtraction. So let's talk about monomials for a second first. A monomial is going to be a coefficient, okay, so some number times a variable, and that variable to a power, okay? So this A can be any number, okay, any constant. It's going to be generally a constant number, like let's say 3, okay? Or maybe -3. It can be anything. It can be a fraction. It can be a square root. It doesn't matter so long as it's real. Okay. And then we have a variable. Okay, this is just typical x, but it doesn't have to be an x. It can be a b. It doesn't matter. And then n has to be a non-negative integer. Okay, so what that means is a whole number. N can be 0, n can be 1, 2, 3, 4, 5, 6, 7, etc., etc., but it can be negative, and it can be, and it has to be a counting number, or 0. Okay, so let's say 3. All right, so if we have -3b to the 3, this is a monomial, okay, monomial. If you stick a bunch of monomials together with addition, okay, add up a bunch of different monomials, you get some polynomials, okay? So polynomials are just a bunch of monomials strung together with addition. So for example, if you have, let's say 17x to the 4th, that's a monomial, plus 2x cubed, another monomial, minus 5x, another monomial, plus 10, okay, another monomial. Each one of these is a monomial, and strung all together, it's a polynomial. We call each of these parts terms. Okay, so that's important. They're each terms. So we know what the coefficient is. It's the number out in front. That's coefficient. Let me highlight these things. So let's do yellow for coefficient. These are the coefficients. Okay, -5 here, and 10. We have our variables. Okay, the variable is going to be x in every case. We have our degree. Okay, this is maybe a little bit tricky because the degree of a monomial is the power. So the degree of this monomial is 4. The degree of this one is 3. The degree of this one is 1. The degree of this one is 0 because there aren't any variables here. But the degree of a polynomial is the largest degree. Okay, so each monomial has its own degree, but the polynomial as a whole also has a degree, and it's going to be the highest power of x. Okay, and then lastly, what does it mean to be like terms? To be like terms means that we have the same power. So, for example, if we have 6x cubed plus 2x squared minus 4x cubed, then 6x cubed and -4x cubed are like terms, okay? This one right here, 2x squared, is not. It's something different. So the reason like terms are important is because we can add and subtract like terms, but we can't add and subtract things that are not like terms. So we can add this with this and get 2x cubed plus 2x squared. The x squared can't be added with the x cubed, the 2x cubed, because they're not like terms, but this one and this one could, and so we can simplify it this way. All right, let's look at some examples from Math Excel. Let's do number 5. So notice that we have two polynomials here, and we want to subtract them. Okay, 3x, let me copy it down real quick, 3x cubed minus 5x squared plus 7x minus 6 minus 7x cubed minus 9x squared minus 7x plus 4. Okay, the very first thing that we're going to need to do with this subtraction is to distribute this negative. Okay, the negative can be kind of tricky and we can forget it. So instead of doing that, I'm going to go ahead and make this into a plus and distribute the negative, which means that everything is going to change signs. Okay, this was positive, but since we distributed the negative, it goes to every single term in the polynomial. Okay, every term in the polynomial in the parentheses. So this was negative, this was positive. Now it switches positive, negative, positive, positive, negative. Okay, once we change this to addition, then it's really easy to add. Look for your like terms. Okay, so this is an x cubed, this is also an x cubed, so we can add them. This is an x squared, this is also an x squared, so we can add those. Okay, we have x to the first power, and we have a negative 6 and a negative 4. All right, so then let's go ahead and add this. These two, we get negative, remember to just add coefficients, negative 4 x cubed. Okay, here we get plus 4 x squared, okay, negative 5x squared and positive 9x squared. Okay, then 7 and 7 is 14x, negative 6 and negative 4 is negative 10. And then there's no more like terms in this, okay? This is not like terms with anything else. There's nothing else we could do. So it's simplified as much as possible. All right, let's look at number 6. Here we need to multiply these two polynomials. We have a binomial here and a trinomial here, and we want to multiply them. Okay, so we're going to multiply them by using distribution. All right, let me write this down. 7x plus 5 times 5x squared plus 6x plus 5. Okay, and we need to distribute. So we're going to distribute each term in the first polynomial to each term in the second. So this 7x needs to be multiplied times each term in the second polynomial, and this 5 needs to be multiplied times each term in the second polynomial. Okay, so let's start with the first one, 7x times 5x squared. Okay, so we multiply the two numbers, get 35, and then we're going to add the exponents on the variables, x to the 3. Okay, 1x here, 2x is here, so 3 total. 7x times 6x and 7x times 5. Okay, and then we're going to do the same thing with the other one, 5 times 5x squared. So just multiply the two numbers and get 25. Okay, x squared. 5 times 6x. And 5 times 5. Okay, now we're going to hunt for some like terms. Do we have any like terms? We have some, oops, I'm missing a squared. I'm sorry, this should be x squared because it was 7x times 6x, so that's x times x. We add the exponents. Okay, now let's look for some like terms. We have this one is like terms with this one, and we have this one is like terms with this one, and I think that's about it. So let's go ahead and write our answer. Add up 35x cubed, 42 plus 25 is 67x squared, and then 35x plus 30x is 65x plus 25. Great.